Good morning, friends. Welcome for this lecture. Today we are going to discuss a critical clearing angle and a critical clearing time of power system stability. Okay, as all of us know that if input power, that is a load, if we increase on the power system, then obviously delta is going to increase. Right? That's what if a PS is increased, then delta 1 is increases. Okay, as we know the equal area, we are speaking in terms of equal area criteria. As we know the area of A1 increases, and equal area criteria means A1 should be equal to A2. Okay, so therefore to find the A2 is equal to A1, what we have to do is delta has to be increased. Okay, till it has its maximum value of delta m. Okay, the maximum allowable limit for this stability is delta m. Of delta 2's value will be delta m. Okay, then what we say is maximum limit is delta m. Okay, so then the system is said to be critically stable. Okay, then the system is said as critically stable. Meaning is, if you this is your power angle curve of a system. Okay, if it is the initial loading, if you increase this loading, okay, so then this line is going to be shifted here. Okay, so this critical clearing means, like, variable parameter will be of this much. Okay, suppose if we increase much more your load, then the space between these two will be reduces. Okay, so this is till this much you can increase the load. Over that you cannot increase the load, then your system will not be stable. This we have studied earlier. Okay, a tip, okay, or you can say at the end position, if you place the PS, then that is called as critically stable system. Okay, so during this, what happens is the angle delta 1 at this condition is called as critical clearing angle. Okay, critical clearing angle, and the corresponding time is called as critical clearing time. Okay, so here critical clearing angle is indicated as delta cc, critical clearing angle. Okay, this can be determined by equal area criteria. Okay, this can be determined by equal area criteria, but so this critical clearing time tcc cannot be found out by equal area criteria. Okay, this has to be calculated from your swing equation. Okay, remember, so this critical clearing time is very important. Okay, so because to design the protective circuit breaker for the system. Okay, so we are going to make use of this swing curve. Once we solve the swing curve, we get a critical clearing time. Okay, so that is also very important for us to design the protective circuit breakers for the system. Okay, now but delta can be, this is critical clearing, delta cc, critical clearing angle, can be calculated by equal area criteria. Okay, let's draw a power angle curve. Okay, for the system, let's draw the power angle curve for the system. So this is a power angle curve, p versus delta. Okay, so this power angle curve is mentioned as pm1, that is before a fault occurs. Okay, and then pm, this is a pm2, this is during a fault occurs. Okay, power angle curve, and this is the after a fault. Okay, so these three are your power angle curves. Okay, so now we'll apply, what we'll do is we'll calculate what is the delta cc. Okay, to calculate that, we'll mention this as x, z and y. XY is 180 degree. Okay, this is the delta, so it is 180 degree. So we'll apply equal area criteria for this system. Okay, let's apply. A1 should be equal to A2, as we know equal area criteria. Okay, when A1 is equal to A2, so let's see what is A1 is. A1 is, observe, A1 is, okay, this is curves. Okay, we have to integrate to find the areas. Let's integrate this. Okay, integrate, this is your A1. A1 will be what, which is a maximum PS. Okay, observe only a part of this one. Okay, PS is maximum, and then this one is a PM2 related, right? PS and PM2. Therefore it is A1 will be PS minus PM2 sine delta. As we know that this PM1 is PM1 into sine delta 1, and then this one is PM3 into sine delta 3, and this is PM2 to sine delta 2. Okay, so therefore according to that formula, so A1 will be what? PS minus PM2 sine delta into d delta. We have to integrate it from delta naught to delta cc. Okay, this is your A1. Now A1 is this, so what is the A2? A2, you come to here, A2 is this much. Okay, A2 is this much, which is greater here? PM3 is greater. Okay, therefore PM3 minus PS we have to take, but PM3's formula is what? PM3 into sine delta. Okay, so you take that PM3 sine delta minus PS and integrate it to find the area of that second area. Delta, it is from delta cc to delta m. Okay, so equate these two, means you have integrated. Now we'll calculate what is this delta cc and what is delta naught and what is the delta m. Let's calculate this, means let's see what is the delta naught. So observe, as we know, PS will be equal to PM1 sine delta naught. Okay, this is with respect to PM1. So from this you can get a delta naught will be what? It is nothing but send PS divided by PM1, and sine, if you send this side, it will be sine inverse of PS by PM1. Okay, similarly, if you would like to get this angle, that is PM3 related. Okay, that is nothing but PM3 into sine delta 3. Okay, to calculate, okay, we require delta m now. So to get this delta m, what you have to do is this total angle minus this much angle if you do. Okay, for example, you can take xy, delta of xy minus delta of xz. If you do, okay, you get angle of this much. Okay, that is nothing but your delta, sorry, this much you get. Okay, that is your delta m. What is this delta xy? What is the delta xy? It is total degree, that is 180 degree. Okay, so observe here, it is 180 degree, right? So delta xz we have to get, ताकि we can minus this, to get a delta m. Let's see this, what is delta xz till this much. Observe here, this is your PM3. With respect to PM3, we can define your PS. PS will be equal to PM3 into sine delta 3. Okay, so this one you now we require only delta 3, means that is delta xz. Okay, that is delta xz, right? I'll write here once again. So from this to this is related with the PM3, so therefore PS will be equal to, in terms of PM3, it is PM3 into sine delta of xz. Okay, we require sine delta xz, so what you have to do is send this first this side, so it will be PS divided by PM, right? Then sine angle you send this side, it will be delta xz will be equal to sine inverse of PS divided by PM3. Okay, so you can take here, that is your angle, that is delta xz angle will be sine inverse of PS divided by PM3. Now we require delta m. From this equation can be written 180 degree, you can mention it as pi, minus delta xz is nothing but your sine inverse of PS divided by PM3. Okay, remember these two formulas. Now we will take, so as we have taken area 1 will be equal to area 2 integration, so integrate that. Okay, if you integrate, separate, see this equation you have to expand, this integration is common for this one as well as this factor, so expand this and integrate it directly. So PS, now integrate, let's afterwards we will substitute the limits of it, upper limit and a lower limit. So let's take PS into d delta, means PS is a constant term, you are integrating with respect to delta, therefore it will be delta. Okay, so that is integration of 1 dx will be x, right? So same way, PS delta plus pm2 sine integration of sine delta is what? It is a minus cos delta, so minus minus will be plus pm2 cos delta. So you have to substitute in a delta place with this upper limit and lower limits. This is equal to pm3 sine delta's integration is pm3 constant, sine delta integration is minus cos delta, okay, and then minus second factor minus ps as it is, integration of 1 is delta, okay. Substitute its limits now. Once you start substituting the limits, let's take in this ps, okay, in this ps first one, ps you keep as it is, in a delta you substitute a upper limit minus lower limit, that is ps will be delta cc minus upper limit minus lower limit plus pm2, cos angle is there, cos of upper limit minus cos of lower limit. Similarly here also substitute the limits. Once you substituted, expand this one, this is ps into delta cc minus ps into delta naught plus expand this one also, pm2 cos delta cc minus pm2 cos delta naught. So similarly we expand in this way, and again you simplify this equation, okay. So here you get a common terms like ps delta cc and ps delta cc can be cancelled each, okay. Write carefully, okay. So then simplify, right, this is equal, our intention is to get delta cos delta cc is equal to what, okay. Simplify these terms. Once you simplify, we get a cos delta cc will be equal to ps of delta m minus delta naught plus pm3 cos delta m minus pm2 cos delta naught divided by pm3 minus pm2. This is in radians, okay. Remember here, if you would like to get only delta cc, will be equal to cos inverse of entire thing, okay. So suppose this is in a radians. Now if you would like to get in a degree, what you have to do is same equation you have to keep into pi by 180 degree, okay. This is about from this we can calculate the critical clearing angle of a power system, okay. As another thing is delta tcc, that is time critically clearing time, that cannot be calculated by this equal area criteria. We are supposed to calculate it by your swing equation, okay. Thank you.